anything about PoCs they want to share or update?
I don't really have an update. I've been working on. I tried at David's suggestion, and thank you. I did a dive into the BOMS, if that's how you say it, stuff, and and I was wondering if I would want to take that approach and leverage that code, but at this point I'm not sure that that's going to work very well for me. So plan B is to recompile Python compiler and
okay.
And add an OmniBOR flag to it. And so I started looking at that last night. But I've had a few minutes and I didn't think of recompiling Python.
You just got very faint.
Oh yeah, that's this microphone is on this laptop. My face has to be about an inch away from it. I don't even know where the microphone is. So anyways, I did some research, but I haven't really gotten very far.
Okay, no, that's fine. I mean, I'm sure other folks who've done implementations can kind of count as well, but a lot of my impression has been 90% of the work is finding the right place to make the code changes in compiler shaped things. And then once you figure out the right places, the actual mechanics are not terrible.
No, I don't think so. I'm probably still going to poke around on the BOMS stuff a little bit more. Just to see, it doesn't make sense to reinvent the wheel.
With Python, this is probably doable without a compiler change. Because of the way dynamic loading in Python works, you can hook into the runtime stack by loading a module and modifying the environment a bit.
If you have a pointer, if you have or could dig up a pointer for that, that sounds like it would be enormously useful to Robert, and quite frankly, utterly fascinating to me, because it doesn't surprise me you could do things like that to Python, but I've not seen the hook.
I'm not
in a previous life, I did stuff like this with Python. I can see what I can dig up. The workflow that I'm imagining for Python is any package that wants to benefit from this simply imports a module. The module modifies the environment it's running in, and data exists after that point. And so in the execution pipe, you would simply put this as a module you load before you enter main, and it's there, right? You don't have to recompile. At least I think it wouldn't require a change, but it does kind of depend on what we want to do inside Python, since it's and that's probably a bigger discussion of, like, for non-pre-compiled languages, where do we hook in? How do we track this data?
Yeah, I've been thinking. Go ahead, Robert.
Yeah, I discovered a flag called compile all, which will force a .py compile.
I'm sorry, but you're really cutting.
Oh yeah, sorry.
That's
because I'm looking at your picture, and when I do that, I move my mouth away from the actual microphone. Because I'm not. Anyways, so I discovered a flag called compile all, which will force a compilation anytime when I get if you want to embed anything,
We're losing you again.
I don't know about this then. Maybe I'll have to use a different laptop next time. Can you hear me now?
Yes.
Okay. So if you want to change the actual .pyc file and write information to that, I don't have a really good solution for that right now. And so Ava, did you have one?
If the goal is to change the content of the PYC file, that I'm not quite sure.
Yeah. I think there's sort of like, there are two directions on this. One is, to the degree that Python compiles things, it would be nice to be able to carry the OmniBOR stuff all the way up from the .py file. The other one is, as I think Ava was mentioning, and I think this is going to probably be true in general of dynamically linked languages, is that having some capacity to introspect. So you can, as she said, sort of import something into the file that contains your main, and then you've got the ability to introspect yourself and in various ways make the stuff available. Also gets to be interesting. I mean, quite frankly, you could approach either or both in whatever order makes sense, because, yeah, I mean, effectively you could approach either or in whatever order makes sense to you and whatever seems most tractable. Because I'm most interested in the exploration part of this process at this stage, because we're going to learn a lot as you're working through your PoC. Does that make sense?
Yep, and I share the same curiosity of what we can learn through this process. It's been a big open question for me for the past year. How do we integrate OmniBOR to enable observation, traceability, all of that in stuff that is not compiled or is runtime compiled? And at least in organizations I've worked with, .pyc files are typically not shipped around. They're not shipped between organizations, and they're not shipped inside an organization between environments, other than the final step, in some cases, from pre-production to production. And so if traceability is only enabled in .pyc files, we lose a lot of the other properties that we're going for with Gitbon between coding, building, release, integration, the next thing. And imagine
my understanding
container is only compiling PYC files and that's run in production. You've lost a lot in the middle there.
Yeah, I will say a difficulty with PYC files as well. And my understanding is that the format is pretty specific to individual versions of the Python implementation, and it breaks pretty readily because it's just treated as like an internal thing that only the Python interpreter needs to care about. I was even just reviewing like what's in the format, and the very first thing is a magic number that specifies exactly which version of Python was used to generate it.
Which would make it relatively easy for OmniBOR to get hooked in if Python itself accepted OmniBOR into the .pyc file format and above magic number, and it's just there.
Yep. Yeah, but it does mean that it's not a very good like shareable sort of distribution artifact that you're going to like send around to people, because it is so specific to, you know, it was made with this version and it's going to run on this version.
Yeah. So I mean, my background on this is extremely dated because I got into Python in the mid-90s, but there was at least a brief period where people were trying to treat compiled .pyc files as the, I don't want to give you my source code because mumble commercial reason, so I will ship you the compiled Python bits. And I've never been a huge fan of security through obscurity, but although amusingly, as much as they don't trust security through obscurity, it turns out insecurity through obscurity is extremely achievable.
Yes, and these sort of magic partially compiled or pre-compiled things are relatively trivial to reverse in most cases.
Yeah.
I remember the same from my TCL days.
Yeah, there's
Robert, I hear mumble from your microphone again. I'm sorry. I think you're talking.
I think I'll keep my comments till next week because I can't rely on this microphone at the moment.
Okay.
If you want to or are able to type them into chat, I'm happy to keep an eye on chat and include your written comments in our conversation. I guess we kind of segued into the Python PoC questions from implementers. The next two items there were runtime resolution of imports and conditional imports. Those sound like potential approaches to this, and pretty much what I'm suggesting is using an import to modify the environment to start generating or tracing OmniBOR data. Do we have anyone on the Java PoC side who can talk about kind of this, if they're thinking of the same approach there?
So my approach with the Java stuff is just to log the Gitoid of the classes that are being loaded into the JVM. And I have not yet worked on or looked at a Maven plugin or a Gradle plugin that will generate the OmniBOR docs. Or basically the Gitoids for both the source and the class files. But what I would see is a correlation between what's loaded into the JVM at runtime versus what was generated at compile time. And I'm not yet sure what should be done with that, but I think that goes into the conversation of how are organizations going to consume OmniBOR doc, receipts, and both for individual runtimes, which is what the PoC is looking at, but also at scale. In other words, if you know that you've got, let's say, 40,000 services running in production, what can OmniBOR tell you about what's running in those services? And it's not, I don't see it as a binary, allow the service to run or don't allow it to run. I see it much more as a risk computation. And I think we started in on that conversation last week, but I'd really like to at some point say, what in a perfect world where we can generate things at various different phases of life cycle, what do we do with them?
Yep.
So I've been thinking a bit about this, sort of trying to put my finger on exactly the concerns I have with this particular use case. And I guess it really comes down to when you're talking about static compilation, like just use C compilation as the sort of generic example, then there's a very clear distinction between the build phase and the execution phase, and they're strongly decoupled. And so anything you do during the build phase, is unaffected by actual execution. Whereas with these Python and Java examples, the loading of like classes and object code effectively is intermingled with execution. And so you suddenly have this security concern that if you don't trust this code for some reason, then you also have to take into account what effect it might be deliberately trying to have on the execution environment that might compromise your ability to actually record this data. But on the other hand, we also have the problem that we haven't really discussed how you authenticate OmniBOR objects in the first place. So we don't necessarily trust static build environments just because an OmniBOR object exists or has been published about a particular build. We don't know exactly, we don't know whether it's provenance or whether it's correct. But it is a little bit simpler just because of that separation between the build phase and the execution phase, so that if you do trust your build phase, you don't have to consider the execution phase at all. And so, I think, David, you mentioned that this could be implemented by putting in a custom class loader that produces metrics about all the classes it loads and stuff. But my understanding is that introducing a class loader is a somewhat privileged operation, but also fairly common. And so it would need to interact with other class loaders that are being installed, which may come from these very same class files, jar files that we don't necessarily trust. So I'm trying to work out, not that we solve the technical problem of how you implement this in Java securely, but how do we put a framing around it that takes that into account? And I think the Python case is very similar in all those respects.
Yeah, no, it's one of those things where the more deeply I think about the how do you know you're secure, the more convinced I am that it's an asymptotic game more than anything else. And so the better question becomes, how clear-eyed are you about where you are on that asymptote? So
I think, David, you're sort of framing of it as like this is a best effort kind of auditing tool or like large scale, like fleet wide. How do we get a general sense of what's out there, rather than like we're not going to treat this as a virus scanner where we're looking for specific bits of malware or something like that necessarily. But obviously, there's a continuum there because Log4j is a specific bit of malware. So,
yes. So I think, and this, I'm sorry, Eva, go ahead.
The way I'm looking at this, and Jeremy, you touched a bit on if you don't trust the provenance of the OmniBOR data, the Gitoid tree itself, that is not there are two scenarios at a high level in which falsified data could enter that pipeline. One is build time and one is distribution process. In principle, this should solve the distribution process gap in a way that a standard SBOM doesn't. If you've embedded the artifact dependency graph, or artifact graph hash in the binary. That doesn't work for non-compiled languages though. But for compiled languages, I think that closes one of those gaps. If you don't trust the compiler that your provider of software used, that's a different problem that we can't solve with this.
I mean, part of the problem is that the manifest being, or the manifest embedded in the binary doesn't really tell you very much about the binary, because I could take an existing binary and replace any embedded manifest with another one. And there would be no strong coupling between, like, there's nothing in the manifest that says I belong to this binary, because it's a binary to manifest edge, not manifest to binary edge in the graph.
Yeah, and that sort of actually brings, go ahead.
Yeah, you do still need some sort of a separate attestation or signature of both documents, right? So something like Record or Skit or any other sort of publication saying, I built these two things, here are these two signatures, hashes, and my signature of that statement. You still need that provenance, right? Totally agree.
Yeah.
Well, I would actually also suggest that you actually, in the embedded case, and I know we have conversations about that coming in later. If I have an artifact in the embedded case that contains the input manifest identifier, then if I sign the artifact, I don't need to sign the rest of the OmniBOR documents because of the Merkle tree properties. And just like when I sign it,
and just replace the content of that as you signed it.
And so part of one of the nice things about that is that people are semi in the habit of signing artifacts at this point, right? And getting more so. We don't have to teach them to sign new things. They just keep signing the things they're signing, and as a side effect, the signature of the artifact becomes an attestation that at the time of the signing, this was in fact the identifier embedded in the artifact, and into which people will infer lots of other less defensible things, but probably with a high degree of correctness about the inference, right? They'll sort of say, oh, well, this was signed, therefore this is actually the real input manifest for the thing. And it's like, that's not quite what that means, but it has a high probability of being true. So
I mean, it also means,
Go ahead.
I just want to say, like, if the build process is compromised, but the signature mechanism is not, then it actually gives you a fairly high confidence that you can identify things that were built by that compromised build process.
Yes. And it's funny because build process compromises, depending on the world you're sitting in, either feel more or less likely. There are certain languages that will let you do insane things as part of their builds, cough, npm cough, that I have no confidence in the build processes in general. But I think there's a certain tendency for people sitting out, say, in C-land to feel more secure, possibly incorrectly about theirs. Quick point though. I did want to suggest. We've had a couple of times we've had to skip past beyond getting to Jeremy's topic on tagging inputs. And I did want to suggest, number one, I think the high level explanation discussion, since we've now merged the changes to the intro spec, I think that discussion is, as a discussion, concluded. Is that correct?
Yeah, I think so. I think we basically completed that.
Okay. Good. So let's count that completed, and then and so anyway, I'll turn it back to you, Ava. But I know a couple of times through Jeremy, we've been involved with other discussions, and we've not quite gotten to your discussion here, and I didn't want to sort of run off that edge again.
Ed, I will actually punt this back to you, since I think you have been party to more of these discussions than I have. I wouldn't quite know how to pick it up.
I would actually want to, if I may, can I punt this to you, Jeremy, and can I hand the ball to you so you can sort of talk folks through what you've written here, because you've written a lot of very good, thoughtful things, but I don't know how many people are fully up to speed on it.
If I'm not the only one who's not up to speed, I would love to get a refresher slash, summary from you, Jeremy, of what should we be thinking about here?
Do you want me to hand you back the ball, Jeremy?
Sure. So as a very I wrote two discussions. I originally had them as one, and I realized they were kind of like two distinct things. One is the convergence and divergence thing, which is sort of like a high level framing of how I've been thinking about the general OmniBOR problem of fundamentally, I like to think about it is that the hashes should be differences in hashes should reflect a difference that matters to you. So if you include absolutely everything in the hash, then it means that any change whatsoever will cause the hash to change. But if those changes are not ones that you're interested in, then the difference in hash just makes you, then you have to dig an extra level down. You have to actually directly compare the artifacts and look for the differences that you care about. Whereas if you only hash the things that matter to you, then a difference in hash necessarily means that the difference is interesting. And well, more specifically, if the hashes are the same, it means that the two artifacts in question are identical in all the ways that you care about. And so the specific example I give there is that if you have an IDL like protobuf and you have an input spec file that gets compiled into a different source file, and you make some comment changes that don't have any material effect on what gets generated, then ideally, you would want the generated files to be identical, so that if you were to compute the OmniBOR graph for that build process, you would see a difference in the source files to the input of the protobuf compiler CodeGen, but the outputs would be identical because they're not materially different as far as you're concerned. And then every subsequent thing that consumes those files would also generate identical artifacts. And so you could very quickly say, I see that there is a difference in this protobuf file, but because all the outputs are identical, or to put it in this terms of this, because all the outputs converge, then I know that that difference in that protobuf file is not interesting or material to the rest of the process that I have. Whereas, of course, you could say, oh, it's a comment change and I don't care about that. But if those comments are being extracted and then turned into documents and you get a different set of documents from that, then the difference in the documentation might be interesting and material to you. So that would have a different hash, even if the generated code sort of object code aspect of it doesn't. And so what the other proposal about input tagging is trying to get to is the idea that initially you can populate your OmniBOR manifests with as much data as you want. And every single piece of data you put in those is going to affect the hash. But if you as a consumer of that data are not interested in some aspects of that data that's encoded into the manifest, then the input tags would let you know what that data is, like what's being referenced in the input manifest and why. And then you can strip it out and then recompute a new derived input manifest without that information. And so then if you do that to all of your build graphs, all of your OmniBOR graphs, then you'll be able to see convergence in the hashes in the aspects that you care about. And like in the current design, all that we have in the input manifest is a whole bunch of other OmniBOR document IDs or OIDs. And we don't know what they're for. So you have no basis to go through and know what you want to remove. So the idea here is that if we tag them with an ID, an identifier that the consumer can understand, then it gives them that ability. But this also ties in very strongly with the ongoing conversation about whether or not we embed these manifest IDs in the binaries, the output artifacts, or if we keep them as a separate graph. And that very fundamentally affects the design as to whether or not there's an edge between an input manifest to the artifact it describes or between the artifact back to the input manifest that describes it. And if you're doing the embedding, then it means that all of this ability to strip out unnecessary information from the manifests is moot because the binaries themselves already have the full manifest, however it was originally computed, embedded as part of their content ID. And so there's nothing much you can do about that. I think that covers everything. I mean, it's
yeah. So one of the thoughts that occurs to me from your discussion about convergence and divergence and embedding is essentially by embedding the input manifest ID into the resulting artifact, what you've basically done is ensure the propagation of any divergence in that input manifest up to the rest of the tree. And so one way you might think about the embedding question is basically whether or not you're going to propagate divergence up tree, if that makes sense. I don't know if that's a useful way to think about it or not, but it was one of the thoughts that occurred to me.
So I mean, this is one of the reasons why sorry.
That's, I think, a really good summary of it, Ed. And it's almost automatically true, if you're embedding the input manifest hash in the binary, then yes, you are propagating divergence of inputs, even when the outputs were otherwise the same. And if you do not embed, then you intrinsically have a much higher convergence, because if the outputs of any build step are identical, even given different inputs, right, then the next step input manifests are the same. So Jeremy, you've probably thought more about this than I have, but are these two properties, convergence and divergence, in addition to the way you frame them here, are they strongly correlated to embedding or not embedding?
Yeah, I think so. Like, I think if you want to increase your convergence because you want to eliminate unnecessary propagation of unnecessary detail, then embedding directly counteracts that.
Okay.
And I think, I mean, you could imagine schemes like you can take the artifact and you can identify exactly which bytes represent the manifest ID and like zero them out or something like that, and then compute the hash over that and sort of like enforce convergence on a particular artifact by eliminating its distinctions. But that's really messy. And the convergence problem, like, I mean, it can go too far. Like when I have prototyped a system like this internally, like the problem is that empty files turn up everywhere and they all hash identically. And so, I call it the empty file problem of like, what's the provenance of an empty file? Well, there's like a zillion different things that generate an empty file. And where did this empty file come from? Like to a certain extent, it doesn't matter because it's 0 bytes long and they're all equivalent. But if you care about like, oh, this binary is an empty file, and sure, it's equivalent to all the other empty files, but Bourne shell treats an empty file as being the same as bin true. So if you can replace a binary with an empty file, then you can make it a binary that always just executes as a no-op and does nothing. And so if that's supposed to be like doing a security check or something, then you've introduced a security problem with your empty file. So like it's often not enough to just consider the file as a sequence of bytes, but also what role it plays in the larger system.
Thank you for teaching me a new way to compress bin true.
Yeah, the original bin true is an empty file.
I did not know that, and I'm infinitely delighted by it. Oh, I think Bharathi has her hand up.
So with regards to this, I think since the convergence and divergence are more context specific, just a thought. So suppose if we embed everything as we do, but the consumer applications, like even for the example of the CV application in the BOM SH, we do, there is a tagging for which is input and output, etc. And if we want to purge something, all the starting from the root of the OmniBOR document, the ADG is prepared. At that time, can they be, customized as to whatever is not interested? We can eliminate them and then build the graph, as opposed to implementing more logic in the way this is constructed in the build tools. I mean, if we go with the non-embedding approach, it's different, but if we have the more context we bring into what we dump in the OmniBOR documents, etc., would just complicate it. But if we add more tags like metadata or whatever way, which can help the consumer applications, purge that graph and clean it up, whatever as appropriate, that might be simpler for the tool development and keeping it more generic, because otherwise all the tools would have to respect these customizations.
No, you've exactly got my point. The idea is that at build time, the tools would put in as much information that could possibly be considered relevant. Like you could put in absolutely everything in the world in there, but you probably wouldn't. But anything that might be relevant to any downstream consumer, the build tools can incorporate, because after all, like it is supposed to be producing the sort of the record of what happened during that build. And so anything that doesn't get included presumably can't be reconstructed after the fact. So anything you ever want there has to be put there. And then, yeah, it's up to the consumers. Like this metadata has enough, the OmniBOR manifests have enough data in them so that the consumers can then customize that to their own requirements as they need. I'm certainly not saying that at build tool time there should be any kind of consideration of filtering this stuff necessarily, because even if you're consuming an artifact from some other tool that includes more information, like if you're GCC and you've got like a set of metadata that you include in your .o files, and you're consuming a C file that was generated by Protobuf, the Protobuf compiler, and it includes a whole bunch of other stuff that you wouldn't necessarily include, but is not relevant to the C to object file transformation, then it's still there. And you don't really have to care about it, the fact that it's still there. But the embedding, as I just said, makes it tricky, because that regardless of what you do, that original sort of set of metadata is always going to leave its mark on those object files.
Yes.
Yeah, I mean, I think, and this may have been what Bharathi's getting to, is basically we've previously talked about a model where you have a skeleton and then you have metadata that points into the skeleton, so that basically you have a very, very, very lean core spec about what you're doing, but a lot of freedom about the kinds of metadata that could be produced. And what I'm trying to wrap my head around is why, for example, you couldn't, the input roles couldn't just be considered metadata against, and please note, I'm not discussing here the embedding versus not embedding, which is a whole other thing, just the input tags piece, right? Because we'll get in a mess if we commingle those in this discussion if you commingle them in what I'm about to say. But why couldn't input tags simply be metadata about that file information, right? So for example, you could imagine then going through, and if I've got a tool that doesn't understand that's a, basically that particular hash is a proto file, but I've got something that could just go through and generate metadata for all the proto files I happen to have laying around that independently. So I can basically generate any kind of input role information as metadata, and it doesn't have to be commingled in time with the build tool, and it doesn't have to be understood by the build tool. Does that make sense? It can be an independent measurement.
So the key question for me is, like, when you're talking about metadata in this way, is it included in the hash or not?
No.
Okay.
It points at the hash.
Right. So my mental model is that if it's not in the hash, it doesn't count as far as OmniBOR is concerned. Because, like, if we have this universe of OIDs, and like, we've talked a lot about the concrete storage of this, but my mental model is that in principle, if you had the means to just have a great big OID cloud in which you could, it's a global universal database of every OID that anyone generates anywhere, and you can reference into it and pick out an OID, then the ability to attach sort of arbitrary unhashed metadata to that kind of breaks that global model. It means that that's purely local state that you can't then confer to someone else. Like if you attach that metadata that's useful to you, but like if I hand those artifacts to you, Ed, and you consume them, then how are you going to find the corresponding metadata for those objects that I gave you?
Well, so I had been thinking a little bit about this, because I tend to think in a little bit more concrete mental models, but I've been thinking about this in terms of, let's say I've got the OID for a thing, right? And I don't see why in your sort of global OID database, why I can't simply say, okay, I've got the OID for the thing, give me the thing, or I've got the OID for the thing, please give me all the metadata you have about the thing, or I've got the OID for the thing, please give me all the metadata of a particular flavor for the thing, and so forth. Like, I don't see why you can't store that way.
So the problem is that if you have the OID, then you know that references a specific sequence of bits, fundamentally.
Mm-hmm. Yes.
But if you then ask for, like, what's the metadata for that, and that metadata is mutable and like not strongly keyed to that OID, in the sense that if someone changes the metadata, like if you look at the metadata today and the metadata tomorrow, you don't know if it's the same metadata or not. Like you can't tell.
It very well may not be, because it may not be a measurement that's done. I think what it really comes down to is which measurements are coincident with the build step versus measurements that may be done independently of the build step, right? Just as an example, if I just wanted to, as you said, identify all the protobuf files, I don't have to identify something as a protobuf file at a particular moment in time as part of the build step, per se. Anyway, I'm rambling a little bit. I'll let you get back to it.
Well, I mean, one of the other things is that, like currently in the current design, inputs are referenced purely by their Git OID, and that kind of means that a particular sequence of bytes will always have the same OID and always look identical no matter where it appears within the artifact graph, regardless of what its role is. So, like going back to the empty file example, if you have an empty file that's used as the input to a build step and an empty file that's used as the input to SHA-1, like you can't exactly tell, what role that empty file is playing in the build process, other than it's an empty file that's being consumed by this build step.
Jeremy, bit of a non sequitur, but I do want to jump in with this while we're in this topic. How is what you're describing as far as input roles and capturing the purpose of the file, even if it is binarily the same file used for a different purpose elsewhere in the build process, how is that different than or similar to things like the new SPDX 3.0 draft SBOM roles?
I'm not sure. I think Andrew pointed me at that, and the list of roles that it had there did seem to be pretty close match for the kinds of things I had in mind.
The more you talk about it, the more it sounds like valuable information to capture for certain use cases that I know the SPDX folks are working on a normalized and very flexible format to capture that. As I look at what's just below the screen share right now, you have a pretty good example. Yeah, the sort of toolchain OID. The invocation details OID might be the sort of nested set of increasingly detailed information. That's the kind of thing that I do think, I'm not an authority on the SPDX3 work, but I've been tracking it for a while. I think that's the kind of stuff that it is being designed to capture. So I'm wondering if these, and I've always envisioned OmniBOR and SPDX or other SBOM formats as complementary data sources. If capturing that in something that's outside of an OmniBOR artifact manifest, but can be directly correlated with one, would meet your goal.
So I mean, I'm trying to think of like there's a range of use cases that I have in mind. Like for example, there's the CVE kind of example in which you kind of really care about, a bug is known in a particular file, does it affect this binary? And in that case, you want a fairly large amount of convergence, and the specific details of how the compiler was invoked and stuff doesn't really matter. But on the other hand, if you want to have like a very rigorous notion of reproducible builds where you want to exactly reproduce, be able to demonstrate that you can rebuild these sources and produce a bit for bit identical output, then you need maximum detail about exactly how that build was performed in order to be able to do that. And so it seems to me that like for that latter case where high degrees of detail are important, then you kind of want that to be in the hash, because otherwise you don't know whether or not a random chunk of metadata that describes how that build was done that's not in the hash, whether that actually corresponds to the build that you're specifically looking at. And I'm not really an expert in the reproducible build space, so that's kind of like a supposition on my part, but
so I do apologize. I have a very hard stop at the top of the hour, so I will have to withdraw.
I also do, but so there's one other thing I just wanted to emphasize on this. The input tagging proposal, like I've talked about stripping stuff, but it actually doesn't preclude adding stuff. Like if you want to rewrite the graph and you have extra context that you want to add onto it, then you can add that as extra fields within the manifests and recompute everything from that basis. And the input tags would mean that someone who gets